We now go on with the program, and our next speaker is Andreas Huber from RAUSCHER, who will speak about making the invisible visible, SWIR technology and its applications. So, Mr. Huber, stage is yours.
Yes, thanks a lot for the introduction. The green one? Okay, now it's working, thanks. So, thanks a lot for joining us today. I hope you all had a good vision show so far. And today we talk about SWIR technology and application. My name is Andreas Huber. I'm sales engineer at RAUSCHER. And yeah, you can make the invisible visible with the SWIR technology. I think the battery is low. Okay, thanks. So the structure for today, shortly I give an introduction about RAUSCHER, then what is shortwave infrared, then I talk very small time about the different sensor types. So I think you all know the CMOS sensors, then we talk shortly about the INGA sensor and the SWIR. And this is very important. When I talk about the INGA sensor, I talk about the traditional INGA sensor because, of course, the Sony SWIR is also an INGA sensor. Then we talk a little bit about the application where you can use SWIR technology, our products, our accessories, and then about the references I used. Okay, so who is RAUSCHER? Some key facts. So we're a leading distributor for machine vision products. We offer hard and software components for your machine vision applications. Our focus is always on all the technical aspects of your application. So we have a really big technical department in our office, and we give you the perfect solution for your application, and we also give a huge design-in support. So if you have any applications, you don't know how you can solve it, we can discuss it, we can perform some feasibility studies, and then we can show that hopefully we can solve the application. We were founded in 1973. By Ernst RAUSCHER. So next year, sadly, there is no vision because we have a jubileum with 50 years, and at the moment we have 16 employees. On the right side, you can see our partners. So of course, Basler is a big partner of us. They release cameras with the SWIR sensors. Then we work with NET. They have traditional INGA sensors. Then we have accessories. Like mid-opt, we offer the filters, Arcova for lenses, and then of course MBJ advanced illumination for lighting, and a lot of other partners. So what is SWIR? Yeah, I think everybody knows light is an electromagnetic wave. The visible spectrum is around about 400 to 780 nanometers. There you can use the standard CMOS sensors. Then there is near infrared from 800 to 900 nanometers, and then shortwave infrared is from 900 to 1700 nanometers. And then you have, of course, extended SWIR and all the other wavelengths. So a short introduction about the different sensor types. So as I said, there are CMOS sensors for the visible spectrum, standard INGA sensors for the SWIR range, and the new Sony SWIR sensor for visible and the SWIR area. Yeah, all sensors have their own spectral response. As I said, CMOS for the vis spectrum, INGAs for SWIR, and SWIR for the whole range from 400 to 1700. And the right side, you see a picture of a standard CMOS sensor. And if you're interested in standard CMOS sensor cameras, at the moment we have more than 500 cameras on stock, so feel free to ask. So I think you remember the right picture of the sensor architecture. It's a standard CMOS sensor with the micro lenses. Then you have the passivation layer if you use RGB. Then you have all the metal lines, and on the downside, the active area. So the left one is frontside illumination, and the right one is backside illuminated, which leads to better response. So standard CMOS sensors are easy to produce, and you reach a really high frame rate. Of course, we also sell the G-pixel sensors with the Basler boost cameras. As you said, we can offer high frame rates. And now you can see the spectral response of the standard InGaAs sensor and the Sony SWIR. As you can see on the left side, we have a really good response from 900 to, let's say, 1700 nanometers. And on the right side, you see a really good spectral response from 400 to also 1700 nanometers. Of course, it's different sensor types. Each type has their own advantages and disadvantages. So the InGaAs sensor has a much better response in the SWIR spectrum, and the SWIR sensor has a good response in the whole range. And the InGaAs sensors has bigger pixels, as we heard the discussion. They're better sensitive to light, and they have a low readout noise, better than the Sony SWIR. Then here we can see the structure of an InGaAs and SWIR sensor. Here you can see on the left side, the indium phosphide layer is much smaller. On the right side it's much smaller, so the red, green and blue light can pass the surface, and then you get a sensitivity in this wavelength. And with the typical InGaAs sensors, the indium phosphide layer is much bigger, and because of that the red, green and blue light is filtered out. Sometimes it's an advantage, sometimes it's a disadvantage, but we have both sensors in our portfolio, so we always have the perfect solution for your application. As I said, the readout noise of the standard InGaAs sensor is much smaller. It's 30 electron volts compared to over 200 with the Sony SWIR sensor, and a higher sensitivity because the pixels are bigger. Now we have a short overview where you can use the SWIR technology. So manufacturing is a good choice. So we do solar panel inspection of semiconductors and level control. You can also use it in agriculture, so you can reduce food waste. Later you can see pictures how this is performed. Then you can optimize your planning for harvesting, and you can optimize your irrigation. And then medical is also an industry where a lot of SWIR cameras are used for blister control, blood inspection, and also for carriers location. So now I have some images for you where it's compared visible light and the SWIR environment. And here you can see you can perform temperature observation. So on the left side, you see a glass. It's red because it's very hot. But on the right side, you can also detect the cracks at the wavelengths of 1450 nanometers. Downside, you can make differences in the temperature visible. So on the left side, you can see visible light. Okay, it's a bit brighter because it's very hot, but on the right side you see the 300 degree iron is much brighter than at 240 degrees. Then you can sort materials. So the SWIR cameras are really often used in the recycling industry. So on the left side you see some black beans, and there are some plastic and metal pieces inside. In the visible spectrum, you don't see big differences, But in the SWIR environment, you can easily locate the plastic and metal pieces. On the downside, you see differences between salt and sugar. So as we all know, in the visible light there is no difference. But sugar appears black if you use a SWIR environment at 1300 nanometers. And so you can easily sort salt and sugar. As I said, these are examples. But in the recycling industry, SWIR cameras are really common. Then you can also do some transmission observation. So you see two pictures of a semiconductor. In the visible light, you can't see through the silicium, but on the right side, silicium gets transparent at 1550 nanometers. And so you can have a check whether this semiconductor is good, is every pin there, is the pin on the right place, and you can have a check when it's assembled. Then, as I said, inspecting solar panels is a very common application. So in visible light, you see it's blue, it looks good, but in the SWIR environment you see a lot of cracks. And here you can imagine if there is a solar park with hundreds of square meters of solar panels, and then you don't get as much electricity as you want, and it's very hard to check each solar panel on its own. So you can use a SWIR camera, make a photo. Of course, you need to do more photos, but then you can locate the bad one and you can change it. Then you can also inspect banknotes. On the left side, you see a standard photo of a 20 € banknote. And on the right side, you see the SWIR environment picture, and there you see the safety features. Here you can visit us at our booth here at Hall 8, C48. There is a line scan application, once with a monochrome camera, then with a SWIR line scan camera, and with a TDI color line scan camera. So it's very impressive, and if you want, you can have a short look. Here you can see a level inspection of water. So on the left side, it's very hard to see the differences because the plastic is very shiny, the water is transparent, but on the right side you see water is black. At 1550 nanometers it appears black, and so you can do a very easy filling inspection. As I said, we can also reduce food wasting. There is an apple, you can locate water. In the visible light, now it looks very good, but on the right side, you see in the SWIR environment, there are some defects and scratches. So maybe you should eat this apple first and then the good ones without any defects. And then we have a sponge. In the visible light, it looks good, it looks dry. But in the SWIR environment, you can detect the wet areas. Then you can also difference the oil and water. It was very funny because I had this application from a customer yesterday. He asked, how can I separate oil and water on my metal surface? I said, oh, here, come to my talk tomorrow, and then I can tell you how you can discern these different liquids. And now you can also see through fog. So if it's a foggy day, you see more or less nothing. But in the SWIR environment, you can see through the fog. And maybe now you're wondering, I say all the time water appears black in SWIR environment and fog appears transparent. But it's regarding the aggregate state. I think on the TV you can see it very good. So at 1400 nanometer, liquid water gets black, and water vapor is transparent at 1500 nanometers. So you should always know your absorption spectrum of your metal or what you want to inspect, and so you can work on the perfect wavelength. So now let's have a short look on our products. Of course, as I said, we offer standard InGaAs cameras. We offer area scan cameras up to 1280 times 1024 pixels. We have different interfaces. We had a bad pixel replacement. We have cameras with linear or logarithmic response. We have them with or without TEC cooling. As I mentioned before, we also have line scan cameras, 2K at 60 kilohertz, bad pixel replacement and also active cooling. And of course, we also offer the Sony SWIR sensor at cameras. So you can come to our booth or at the Basler booth. You see the SWIR ACE2. It was released this week at the first Vision Day. It has the sugar cube housing, 29 times 29 millimeter housing. It has GigE or USB interface, and it's available in VGA and with 1.3 megapixels resolution. Then, of course, we offer the whole portfolio, so the products and also the accessories. So we have lenses for SWIR cameras and also for the visible and SWIR spectrum. We offer lights. This is a very important topic because there are not many light manufacturers for SWIR applications. Then we also offer the filter and the cables and interface cards. So thanks a lot for joining us today. As I said, come to our booth, C48, and then we can discuss some specific applications if you want. And last but not least, the references. Thanks.
Thank you very much. So we saw an impressive new sensor technology, which is already in the cameras and ready to use, provided by RAUSCHER. Are there any questions? If this is not the case, oh, okay, of course, Mr. Sonder.
Yes, COVA released the optics for visible and the SWIR spectrum. Yes.
Okay,
yes.
Impressive. Thank you.
Okay, thanks for the question. Okay, if there are no further questions, then good presentation.
Thanks.
And we will end this session here. Thank you very much.